Welcome to another good example of using the Gauss-Jordan elimination method, one of the many methods that you can use to solve simultaneous linear equations. And here are two linear equations, and they're already in the correct format. You have the x and the y on the left, and the constants on the right, and that's an absolute must if you're going to use this method. So the next thing you do is you draw something that looks kind of like a determinant with a little dashed line in between. To the left of the dashed line, you put in the coefficients of the x and the y. So this is a 3, a 5, a 2, and a 3. And to the right of the dashed line, you put in the two constants, 9 and 5. And then you're going to go through a set of operations dictated by the Gauss-Jordan elimination method until you end up with something that looks like this, where on the left side, you get a 1 and a 1 on the diagonal and a 0 and 0 everywhere else. And here, you'll then be able to just simply read off the x and the y value of the coordinates of the point where the two lines cross. So to do that, you must go through these various steps to turn this into that. And you always start with the upper left corner. And the first thing you want to do is turn this 3 into a 1. And you can do that by simply taking the whole first row and divide the whole row by 3. And remember, whenever you use the Gauss-Jordan elimination method, you must do exactly the same thing to everything in the same row, which means you must do the exact thing in everything in the same equation, or do the same thing in both sides of the equation. So we're going to take the first row and replace it by 1/3 the first row. That's the same thing as saying I'm going to take the first row and dividing by 3. When you do that, you get the following. You get 3 divided by 3 is 1. 5 divided by 3 is 5 over 3. 9 divided by 3 is 3. And the second row goes unchanged. All right, we're partway there. We have now taken our first number right here and turned it into a 1 to make it look like this. The second thing we want to do is take this number right here and turn it into a 0. How do we do that? Well, the methodology says that we take the second row and replace it by the negative of this number times the row with the 1 in it and adding it to the row that we're trying to change. So we're going to multiply this by negative 2, which gives us a negative 2, add it to the 2 to turn into a 0. Okay, if we do that, we get the following. Now notice we're not changing the first row at all, so we can rewrite that. 1, 5 over 3, and 3. Multiplying this 1 by negative 2, that gives us negative 2, added to 2 gives me 0. Multiplying this by negative 2, so negative 2 times r1 means negative 2 times this. Negative 2 times this gives me a negative 10 over 3, and I add that to 3. Now let's do that on the side. We have negative 10 over 3 added to 3 is the same as negative 10 over 3 adding it to 9 over 3, which is minus 1 over 3. So if I multiply this by negative 2, I get negative 10 over 3. I add it to 3, I will get negative 1 over 3, and I put that down in here. Over here, I'm multiplying the 3 by negative 2. That gives me negative 6. Added to 5, that gives me a negative 1. All right, halfway there. I get the 3 and the 2 now changed to 1 and a 0, which is exactly what I want. So next, I work on this number right here. I go to the second column, and I go to the number where I want to change it to a 1. To do that, I need to take this number and multiply it times a negative 3. If I multiply this by negative 3, I get 1. So that means I'm going to take my second row and replace it by negative 3 times the second row. Simply said, I'm taking the whole second row and multiplying every number in the second row by negative 3. When I do that, I get the following. Notice that nothing changes in the first row, so that still remains as a 1, a 5 over 3, and a 3. The 0 doesn't change. If I multiply this by a negative 3, I get a 1. If I multiply this by negative 3, I get a 3. Almost there. Notice I have a 1, a 0, and a 1, just what I need over here. Now I need to take this number and turn it into a 0. And using the Gauss-Jordan elimination method, the rule is that you take the first row, the row you want to change the number in, and replace it by the negative of this number, which is minus 5 over 3, multiply times the row that has the 1 in it, which in this case is R2, and add it to the row that you're changing, which is R1. So simply said, take this number, multiply it by -5/3, and add it to that number, and it'll turn into a 0. If we do that, what do we get? Well, first of all, the second row does not change, 0, 1, and 3. In the first row, this is already a 1 that will not change. Now, taking this number, multiply times -5/3 times that number, that's -5/3, add it to +5/3 gives me a 0. Taking this number, multiply times the -5/3, notice if I multiply this times this, the 3's cancel out, and I end up with -5, add it to a +3, I end up with a -2. And now I'm done, because I have the exact values for x and y. I have 1, 1, and 0, 0 on the left side, so that's how I know I'm done. And I can then say that x equals -2 and y equals +3. And just to make sure we did it correctly, let's plug those values back in the original equations. So we're going to check. 3x plus 5y equals 9. Plug in -2 for x and a +3 for y. So 3 times -2 plus 5 times 3. Is that indeed equal to 9? So -6 plus 15. Yes, indeed. That's 9. So that's correct. And one more check, taking the second equation. So we have 2x plus 3y equals 5. Again, plugging in the -2 and 3 for x and y, we get 2 times -2 plus 3 times 3 equals 5, or -4 plus 9. Yes, indeed, that's equal to 5. So we just saw that we did it correctly. And those are the x and y coordinates. You can also write it like this. X equals -2, y equals 3. There's my solution to those two equations. That's the point where the two equations cross.